For this recording, we are going to look at angle bisectors, and how they determine the location of the incenter. As a reminder, an angle bisector divides an angle into two congruent angles. And where these angle bisectors intersect, or again, are concurrent, represents the incenter. So when we look at, because it is an angle bisector, when we look at these angles here, we have angle EAD. We're looking at this angle. It would be congruent to angle CAD. Angle FCD would be congruent to angle BCD. And angle GBE would be congruent to angle AB. So if you know where the point where the incenter is, then you also know that these pairs of angles will be congruent. Now, the interesting thing about the incenter is that the perpendicular distance from the incenter to the sides of the triangle are congruent. So this distance is congruent to this distance, turn this way, and this distance. So I'm going to label these J, H, and K. So because they are congruent, HD is congruent to JD, which would be congruent to KD. And what you can do if you have a compass is you can put the point of your compass here, and you can draw a circle that will be tangent to the sides of each of the triangles. So this is the incenter. Will give you a circle that is inscribed in the triangle. So just as we've done in the previous triangles, in an acute triangle, the incenter is located inside, the same for obtuse, and the same for a right triangle. So the incenter is always found in the interior of the triangle, and it is where the angle bisectors are congruent.